Alright guys, I'm going to give you a few tips on using making custom boards for the Atmega 2560 chip and using the common 2.4 inch TFT touchscreen and making it all work good and faster screen refresh. So first off, you need the chip, and you know your project with these screens, they use up just about all the pins on the Arduino Uno chip. So then you're kind of forced to go to the Arduino Mega chip to use this screen and do other things at the same time. So to use this chip, if you were to buy just the loose chips, then you have to be able to burn the bootloader. So if you're going to have to be able to burn the bootloader, then you're going to need one of these sockets like this. So be aware that you need to be able to burn the bootloader onto it before you can program it. So you have to have a socket. Unless you just buy these Arduino Megas, you get them on eBay for $10, and just use a hot air solder gun and desolder the chip. If you're going to do it that way, then you do not need to worry about having a socket. You can just slap them on there. So either way, you gotta understand how you're going to get the chip first, if it's going to come with a bootloader or not. So now with these chips, or with these screens, we use the MCU Friend KBV master KBV library to run these screens. Now the problem with that is that the pinout on a regular Arduino Mega, the pinout makes it have a slow screen refresh. So since we want to make our own custom board for our custom project, we're able to change the pinout and give ourselves a faster pin refresh. So if you notice here, I got all these digital pins for the screen are all going to the L port L, and that makes it just a single port, like L0 goes to 0, L1 goes to 1, and so on. Yeah, I made a mistake on this board, and I had to make a jumper because I didn't realize that Arduino Mega, the software serial only works on certain pins, so I had the boards designed wrong. That's because the software serial is why I had to make the jumper. But yeah, we use the L port and just one single port instead of jumping back and forth between ports, and that's what makes your screen refresh faster with these 2.4 touchscreens. So this one's the same way. You can see they're all coming off of the bottom, which is the L port. And so how to change to the L port in the library is kind of complicated. I tried to pay a guy to do it for me once, and he couldn't figure it out. So I finally figured it out. What you do is you go to your library, utility, and then you go to MCU Friends Special, and you open that up. I've already got that opened up in WordPad. And then you scroll down about this far here, and you get down to LSIF, define, Arduino Atmega 2560 used Mega 8-bit Proto Shield. And if you look at this one, it uses port F, which is the regular ones, just like on the Shield for the analog pins and stuff. But for them 8 digitals, it uses port A and port A only. In this one example in the special, you only uses port A. So I took this one, I just turned this A to an L, 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 and then I copied and pasted this, and that makes it work on port L only, and it gives you a super fast refresh rate, screen refresh rate. It does not affect how fast it loads a BMP picture in, but it does affect how fast the screen refreshes under normal circumstances. So what I did was I just changed these A's to an L, copied this whole thing, and I put it into the main folder, because I could never figure out how to get the library to utilize something in the special folder. I tried a couple times and gave up and just put it in the main folder. I'm sure there's a way to do it. I just got tired of trying. So this one MCU Friend Shield is the main folder where it gets the macros for the pinout from. So if we open this, first it goes, see, I've even tried using define, use special, and I couldn't never get that to work for some reason. So I'm sure there's a way to make it work. I got too fed up and I just did it a different way. So this is the Atmega 328, and then the next one down is the Atmega 2560. I just erased, well, first off, I backed up the whole folder, and then I erased this, and then I I pasted in what I copied over with these changed to port L. These 3, just change the A's to the L's, copy and paste it into here, have this correct heading here. You want this to be the same. You just want to paste all this over here. And that's how you change it. And it will use this pinout and work with the port L. Before, it was splitting it up between at least 2 or more ports, and that's what was slowing it down. So that's one way to doing it. If you can figure out how to get it to actually use the special folder, that would be a better way. But I tried a couple times and I got fed up, and I just copied and pasted it in here. So you just take that one that only uses port A and you change it to port L, and that's how you do that part for the library. So now it only uses port L. L0 goes to 0, and you don't want to just go in order. You see, see if I can focus on that. D0 starts over here, 0, 1, and then it goes back up to 0, 2, 0, 3. Well, you have to have L0 start here, L1, L2. You got to follow the right numbers, not just where they're located on the board. And then you can get the fast refresh rate. And I get these custom boards done, and from Easy EDA. It goes to that company they work with, whatever that's called, and they come out good. Obviously I messed one up here, but and then I use these little bitty crystals. These are pretty useful because they don't take up as much space as you get them big ones. That's compare that little bitty tiny thing to that big one there, you know. And this one here has a built-in, it has the 2 capacitors built into it, so it doesn't need any capacitors at all. You just hook up the 2 crystal wires and a ground, and that's all you need. And so if you're interested in that chip, or I mean that crystal, this is the part number, CSTCE16, and it is an SMD3 pad setup. And the trick to them is you go really light on the solder paste, and then you use your hot air gun. And then once you're done, you get your multimeter and you put your probes in there, and you make sure the ground's the middle one. So you make sure there's not a short between the outer legs and the ground, just to make sure, because it's a little tricky one to do. And if you use too much solder, you can make it short out, and so you got to check it after you solder it to make sure there's not a short between those two and the center one. And then, you know, I just I 3D print these boxes, and then I use these 18650 vapor batteries, and then I use AA. If you go on to eBay and stuff, you can get these a bag of these. They're for AA batteries. These metal spring stuff, and the other piece, the flat end. I just use the ones for AA's, and then I just make a battery box, and I use just a simple voltage regulator and stuff, and then this is just one of my projects I got going. And what I do is I bring the TX, the RX, and the reset and the ground out to a 4-pin female header. And that way I can just program these using the USB to TTL and plug them into there, program it, and it's good to go. Now, like I said before, if you're buying the loose chips that don't have a bootloader on them, you have to get this socket over here, and yeah, and then you get your custom boards made. You're going to want a voltage regulator and a crystal and a way to program it. Depending on your setup, for some reason this voltage regulator was getting hot, so I had to put a heat sink on it. But and then I just use two 10K resistors to make a voltage divider to monitor the percentage of the battery, or the voltage of the batteries, so I can tell how much battery is left, because that's 8.4 volts altogether. So I just divide that in half with the voltage divider, two 10K resistors. This one is that's GPS module, and this spot right here is for a digital compass module. And this is kind of my new regular platform that I do stuff with. I 3D print these battery boxes. I use a Arduino Mega chip, and I use these cheap 2.4-inch colored touchscreens, and then I add whatever else I got going on in my project to it, and it works out pretty good as a platform for everything. I mean, yeah, the touchscreen uses a lot of pins, but if you use a Mega, that ain't an issue. It's nice to have this nice user interface. I mean, let me put the battery back in this thing. You know, I can do all kinds of stuff. See, now I gotta actually turn the button, touchscreen button down because it refreshes the screen so quickly. It's almost too fast. Now, this one uses the original pinout for the Atmega that uses multiple ports, and you can see how slow the screen refresh is compared to the other one that's just super fast using the L port. So that's the reason I did that, and it all depends on what your project is, you know. But it's nice to know, because I couldn't find that. I had to figure all that out. That information is not available. I even tried to pay a guy to change the macros in the library for me, and he couldn't figure it out. So I eventually figured out a way around everything, you know. But yeah, this is my new platform setup, you know. These batteries and a Mega and this touchscreen. I'm going to be using it for all kinds of things. Just wanted to give you a rundown of how to utilize this screen and how to change that library macros, and hopefully this helps somebody. Later.